Hello, students. I welcome you to your Friday recitation video. And first things first, let me say that I am here to help you, and so please contact me with questions. My job is to try and get you help as soon as I can, and that is what I intend to do. In order to make that happen as smoothly as possible, I recommend that if you can email me a picture of the original question and like any written work that you've done type of stuff, that usually makes it very easy to point and say, here's where I'm stuck. Also, I recommend sending a short comment that makes that very clear. If you just send a picture of the problem, then I don't know where you're stuck or what you're having trouble with, and I'll just send you the wrong answer sort of thing. So please, that's probably what I recommend is the quickest way to sort of be able to get an answer. If need be, I will be available to schedule a Zoom session or email or share videos like this back and forth. And so we'll be able to get your question answered. So please contact me and I will be able to try and get to that stuff as quickly as I can. And I'm here to help. So moving on, for Fridays, I want to start by on Wednesday nights, I'll try and send out a reminder and you can send me back questions and topics you'd like me to cover sort of on Thursday, so that if I got those by Thursday afternoon, I will be able to put a video out by 8 a.m. on Friday on Canvas. So in order to put out a video by Friday morning, I need to get the stuff by Thursday afternoon, so I'll send out a reminder on Wednesday. I will be available starting at 8 o'clock on Zoom until the end of your quiz. The first half hour of that from 8 to 8:30, we'll just sort of be able to answer questions and get to anything I didn't get to on the video, that sort of thing, and then your quiz will start and I'll be able to answer any questions you have during the quiz. The quiz is available starting on Canvas at 8:30 a.m. and it should give you sort of a half an hour to finish it, plus a little bit of time to finish uploading. And if you're a DSP student who's got additional accommodations, that should already be hopefully entered into Canvas correctly, so it's just a matter of making sure that's done correct. Okay, that said, let's move on and get to a few problems that I hope are somewhat helpful. So the first one is just to compute an example of a dot product, and it gives us two vectors, a vector A and a vector B. And to compute the dot product, we line up corresponding indices. So here, like the first one, we line up the 1 with the 4. We multiply those together, 1 times 4. We add that to doing the same for all the other indices. So the 2 times the 3 plus the 3 times the negative 2 plus the 4 times the negative 1. And we should note if we add those up, 4 plus 6 minus 4 gives us 0, which implies that these two vectors A and B are orthogonal. Or another way of saying that is they're perpendicular, or the angle between them is 90 degrees. What if we tried to compute the cross product of these two? Well, we should note that the cross product only works in R3. These vectors live in 4 dimensions because they have 4 components. So we can't compute the cross product of A and B. But we can compute cross products. So an example of that would be if we were to compute the cross product of an arbitrary vector that's in the xy plane with the normal k-hat vector. So this is thinking of the xy plane as in part of R3, so just the xy part. So an arbitrary vector in the xy plane, we could give it the name v, would have some x component, some y component, but the z component would be 0. Our k hat vector is the typical 0, 0, 1. So in order to compute the cross product of these two, we set up, try and do it that way. The cross product is equal to the determinant of setting up the matrix this way. So we have I, J, K. We need to remember order matters. V cross K is not the same as K cross V. So if I do V cross K, I need to enter V here and K here. So we put the components for V, X, Y, 0, and the components for K, 0, 0, 1. In order to compute the determinant, we select the first one. We take it times the product minus the product. So y times 1 minus 0 times 0. Y times 1 minus 0 times 0 is y. The second component, we put a negative sign. Sometimes people just do the opposite order thing here. Don't mean to confuse you. I like putting a negative sign. So negative j hat times x times 1 minus 0 times 0. That's x. And then k hat times x times 0 minus y times 0. That's 0. So putting those together, we could write that as y I hat minus x j hat, or writing it in component form, we have y minus x and 0. So we should somewhat see what's going on here. So if we were to think of our normal xy plane with our z-axis pointing directly up towards the camera, then our vector v would have some xy components and no z component. And if we were to take the cross product of that with our z, we point our fingers towards v, curl them towards z, and we notice that it points down in this direction, 90 degrees from both of those, which gives us this vector. And we can really see that our right-hand rule for the cross product ends up rotating things to the right. Kind of a fun little thing to see. Anyway, just to review one more time, how do we compute the determinant? I hat times y times 1 minus 0 times 0 minus j hat times x times 1 minus 0 times 0 plus k hat times x times 0 minus y times 0 gives us our final answer. Hope that helped. Thank you much. See you soon.